just want to show you a few things before we start. So on the Canvas, if you go to Files, I put up, and I'll probably play around with it a little bit towards the end of class today before we talk about this week's paper. But I put an Excel file up here. I'm going to show you how to do a few things in Excel, kind of get some basic statistics, also how we can run a simple linear regression in Excel. So these are, once again, these are all kind of building the tools to be able to apply to kind of your project. Related to your project, the list I put up is not like, I think maybe there's a little confusion. Those are things I've seen in the past or ideas I think would be good project ideas that I have data for. Well, you can choose any topic you want. And you know, it's not like you have to reserve one of those topics, right? You can choose whatever topic you want. You can come up with your own or one off that list, okay? I should be able to start kind of getting some of those data sets out early next week, hopefully. I've got some time scheduled out to kind of start working on those. And for those of you who have emailed me, kind of start getting those out, okay? We still got a few weeks until kind of it's due for you to give me an actual topic, right? So we left off last class discussing this idea of revenue sharing. So we'll talk about it a little bit, and then I'll kind of go through, I'll do another graph similar to what we did last class, just to kind of make sure we have a pretty good understanding. So revenue sharing, right, we kind of talked about, varies across the different leagues. You know, you can think about maybe we could rank them, you know, NFL probably has the most. But some of the effects that we saw from that revenue sharing, one of the things that we talked about was every single team, no matter large or small, is going to see this shift downward in their demand and marginal revenue curve. Because they no longer are keeping every dollar they earn, they're only keeping, say, 50 cents of it, right, depending on what the revenue sharing rules are. So with these lower quality teams, if they are profit maximizing, they're going to receive more revenue through this revenue sharing program than what they're paying in, right? Because kind of on average, the average that gets paid, those large market teams are paying way more in to this revenue that gets shared than they are, right? So for them, if they're profit maximizing, their incentives might just be that I'm trying to keep costs low, and when I receive this additional money that's not tied to the number of games I win, I'm just going to keep it all, right? So their incentive is to kind of have high, you know, increased profits or have high revenue. They're not necessarily concerned about winning. We said that they're going to stay at that lower targeted number of wins. Okay? For the more profitable teams or these large market teams, right, we talked about their shift in the demand curve is just going to be a higher amount of dollars, right? 50% of 100 million is a lot more than 50% of 10 million, right? So they're going to see this great reduction in their incentives to actually win, and therefore they might target a lower number of optimal wins with their spending behaviors as well, okay? So revenue sharing is going to kind of decrease, right, the target number of wins from all teams, regardless of market size, if they're profit maximizing. Now we talked about, and I'll draw here in a second, the kind of saving grace for this is if we have small market teams who are win maximizing, this may provide an ability to actually target a higher number of wins than prior, okay? But if they aren't win maximizing, they're just profit maximizing, we kind of end up with this, you know, they call it like a welfare class, where essentially they're not doing anything to try to win more games. They're just collecting this additional shared revenue from the leagues and just holding on to it. Or kind of thought differently, this is kind of what we call like the tragedy of the commons, right? If you give, you know, if the additional revenue isn't tied to winning, then these teams are, you know, it's always optimal for me to be the team that doesn't spend more money, but just collects and keeps that revenue sharing or that shared revenue from the league. Okay? So I left this kind of open. I want to just review how we kind of think about this. Maybe explain, I think, in a slightly better way than maybe I did on Tuesday, a couple of the concepts. So there we go. So we've got the number of wins on our x-axis. And I think about we've got dollars on our y-axis, right? We said for simplicity, we'll keep the marginal cost constant, right? And we then said, okay, there's some demand curve for wins. And if these are teams that have a monopoly in the market, they'll also face this twice as steep marginal revenue curve. So we said the profit maximizing point is where marginal revenue is equal to marginal cost, right? That would be the targeted number of wins. Okay? We also said that without revenue sharing, we could think about, and this is ATR if you can't quite read that, but the demand curve is really the average total revenue curve. And the reason why was because average total revenue is just total revenue over quantity. Total revenue was price times quantity over quantity. And right, we have an equation for demand that starts out with P is equal to A plus B times Q. Right? You can kind of think about, we could plug in our demand, and here our Q is actually the number of wins. So I guess if you want to kind of keep this a little bit better, we could write in here, instead of Q's, our quantity is now the number of wins. Okay? So that meant that the point at which profits were equal to 0 was where a win maximizing team would go. So here, think about profit maximizer. Here was where our win maximizing teams would go. Because this was the point where profits were equal to 0. Because if we think about how can I write profits? Well, profits is just total revenue minus total costs. So price times quantity, well, price times the number of wins minus, if we have constant marginal costs, then it would just be the marginal cost times the number of wins. Pull the W out front. And the point at which profits would be equal to 0 is when price was equal to the marginal cost. Remember, we could plug in for price our demand curve. So that's the point at which profits were equal to 0, right? Where that demand curve or the kind of price was equal to our marginal cost. Okay? However, if we had revenue sharing, we said, well, this is no longer price times the number of wins, right? Or the demand curve times the number of wins. That no longer represents the total revenue because I'm getting this additional revenue from the league, right? So, you know, we could draw, there would be a shift downward in these demand and marginal revenue curves if we had revenue sharing. But let's just pretend like we've already drawn that shift in. And now our demand no longer represents the average total revenue. There's going to be a curve out here such that average total revenue is greater than our demand curve. So why does that occur? And we also said the new point that if I'm win maximizing, I could get to with this additional revenue. I'll kind of give a little, so W, win is my subscript, and I just put a little dash to represent. If we had revenue sharing, there's just going to be this new average total revenue curve. So we're no longer kind of constrained to just get to this point because profits are actually still positive here. And I'll show you why in just a second. Profits are actually now 0, where the marginal cost is equal to my average total revenue, okay? So this is kind of a little bit of a trick, I guess, in that one of the questions on that last online quiz. I'm actually going to go back in and give kind of credit for 2 of the possible answers. So, because I didn't specify whether or not we had revenue sharing. If we don't have revenue sharing, yes, win maximizing teams choose to the optimal number of wins where the marginal cost curve is equal to the demand curve. But if we do have revenue sharing, it's actually the point where marginal cost is equal to my average total revenue. Now, the weird kind of thing is, if I don't have revenue sharing, my demand curve was the average total revenue. So actually saying the win maximizing team chooses where marginal cost is equal to average total revenue applies to every scenario. You don't even need to know if they're revenue sharing or not. And that's why I originally left it out of that question, because the rule, regardless of whether or not we have revenue sharing, should be a win maximizing team chooses to win where that average total revenue is equal to marginal cost. It's just that without revenue sharing, that's my demand curve. But with revenue sharing, average total revenue is a little bit higher. Okay? Any questions up to this point? You good with this? Let me make sure I look back here. No questions in the chat. Okay. So, just kind of as a reminder, this is what we had without revenue sharing. With revenue sharing, we can think about profits are going to be total revenue minus total costs. Right? I can rewrite my total revenue as kind of that price times the number of wins, or where I'm at in the demand curve times the number of wins. But there's also this additional component, which is the amount of money I'm getting from the lead, right? That revenue sharing money. My total costs are still kind of the number of wins times my constant marginal cost, right? It's the same as we had up there. So now if I think about where do profits equal zero, well, I'm going to rearrange this and I can see now if price was equal to marginal cost, my profits would still be, right? If this is zero, my profits would still be the amount of money I had from revenue sharing. So the point at which profits are going to be equal to zero is no longer where the price is equal to the marginal cost, but it's where, you know, if I can continue to essentially pay that marginal cost even when it's above the demand curve, right? I'm experiencing losses there in profit, but that's okay because I now have this additional money to cover it. Okay? So the new point at which profits are equal to zero is at the point where I've spent kind of all those additional revenue sharing dollars that the league gave me. Okay? Any questions on that before we keep moving? Okay. All right, I'm going to switch back to the slides here. Hopefully, if anyone need any more time with this, are we okay? Okay. So, it's kind of a review, kind of going over things a little bit more in detail than last class, kind of thinking about this revenue sharing with win maximizers. So, we talked a lot last class about revenues, right? Different sources. So what about the cost, right? So there's all this revenue that comes, you know, these teams and these different sources, but what are their costs? So if we think try to break it down, we're not going to spend as much time. We'll dive more into the labor costs later on in this course, but basically most of their costs are going to be coming from those players' salaries, right? If we think about especially what the costs that they can control, you know, they have, you know, travel costs, player development, marketing. There definitely are additional costs, but primarily kind of the majority of their expenses come from these player salaries, right? However, that's if we're just thinking about explicit costs, right? We can start to also now consider some implicit costs for these teams, right? So if I'm the Indianapolis Colts, I don't know, and I'm playing out of Indianapolis, one of my big costs is the amount of money I could be making if I was in a larger city. If there was a larger city available for me to play in, I don't know what that would be off the top of my head right now. I mean, go back a couple years and maybe India was thinking about moving to Vegas, a larger city with potentially higher demand. The opportunity costs of playing in Indianapolis are what I'm losing out on by not kind of having my team in Las Vegas. Right? Now, for different teams, you know, thinking about different locations, some of them may have higher demands in Las Vegas than others because maybe they have a more loyal fan base, and so if they move, not as many people follow, and so, you know, different teams could face different opportunity costs from playing even within the same city, right? So, you know, we've kind of already mentioned this, but it's the, you know, how much we're foregoing by playing in the city that we're in and not moving to the next, really to the city that would have the highest profits. What's going on here? There we go. All right. Now, if those opportunity costs get high enough to where if I moved, I would actually increase my profits, then the optimal or the rational thing for a team to do would be to move, right? It doesn't matter what my current profits are. I could be earning positive current profits, but if I could earn even higher profits by moving to a different city, right, and reducing my opportunity costs, then that's what I should be choosing to do. So we see a lot of teams do this, you know, kind of some of the more recent ones. We've got examples in baseball. We've got examples in the NBA. We have examples pretty recently in the NFL where teams move from smaller cities, kind of San Diego and St. Louis. And actually, this was a very unique one because we had the Chargers and the Rams, so a San Diego and a St. Louis team, both moved to LA. Well, if you think about this, when one team moves, yeah, I don't think many people would argue that LA probably has a higher demand or higher ability and willingness to pay because they're just going to have way more people that have a much higher incomes than maybe in St. Louis. However, I'm no longer facing that entire demand. I'm splitting it with another team, right? So this is kind of a unique scenario where these teams, and they knew the other team was moving, so they had to believe that the profits they could earn by splitting LA's demand was greater than the profits they were currently earning in San Diego or in St. Louis, right? Now, I don't think that's a wild stretch because LA just is so large and there is such a kind of high demand for football to come back to the city that, that's why, we can think about it maybe made sense, right? Think about it this way. If I'm splitting half of Indianapolis's demand and having a team there, that's probably still better off than being the only team in Muncie, right? So that's kind of the idea that we have going on there. Okay? Any questions on this for keep moving? Shouldn't be too bad. So, we can think about some of the additional costs, kind of the opportunity costs kind of coming up here. Starts to let us think about some other issues, right? So when we look at these reported profit amounts from teams, first of all, we need to be very skeptical, right? Most of these teams are probably reporting what type of profits. I think I kind of mentioned this last class. So we've got, in economics, we have two different types of profits we talk about. One is, there are two different majors in the business building. So we've got accounting profits and we've got economic profits, right? Accounting profits wouldn't factor in things like opportunity costs, right? They kind of focus on explicit costs, not these implicit costs, right, of not being in those other cities. Okay? So right away, when we see these reported profit amounts, they're not factoring in some of these opportunity costs. Okay? With that in mind, and we also can think about some of these owners are going to have their own agendas, right? So even if we see a team that has negative profits, why could that exist? Right? We'll think about why that could exist. So, a good example of this is in Japan. A lot of their baseball teams are really just owned by larger companies or used by larger companies essentially as a marketing source. So they don't care if they lose money operating that baseball team because what they're spending, they think they're making that money on a different product, right? I'm okay, the age-old example is I'm okay running a special on milk and eggs if I lose money on milk and eggs, but it brings people into the store and I make way more money on the rest of the goods that I'm selling, right? So that's the idea here. If these teams are owned by other companies or the owners have other companies and they're just using this as a marketing tool, well, then I'm okay if I see some accounting even losses or economic profit losses because I'm probably able to make up for those with this other product I sell that isn't a sports-related product, okay? The Anaheim Ducks were owned at one point by Walt Disney, and so you can kind of think about a similar story would exist there. Or maybe the owners, right, just don't care. They're not trying to, this is a hard one for us to factor into our models, but potentially they're not, when we think about win maximizing, and I say we have to stop at the point where profits are equal to zero, well, that's only true if I'm only operating this one company. If I'm operating another company that's able to earn positive profits, well, I can always take that money and just spend it on that team to push out to a further point, right? I can experience negative profits in my football team if my oil company is earning positive economic profits, right? So that potentially is going on, and that's going to be very hard for us to measure. A project idea that might be lofty, but I imagine you could probably get a good amount of the data on is to look and see the performance of teams and look at the wealth of their owners or the profitability of their owners' companies and see how those two things are correlated, that could be really interesting, right? And that would be one way we could try to start capturing this idea that I can actually earn negative profits if I've got another company that I can kind of take some of that money and move it over, okay? We already mentioned this. There's a difference between accounting and economic profits. So we might see that teams have negative accounting profits. However, just because we don't see negative accounting profits doesn't mean that they in fact aren't. So we talked a little bit last class about vertical integration, right? So, if we think about here, Turner Broadcast System and the Braves were owned by the same person. So the Braves were essentially selling their local broadcast rights at a price of $0 to TBS, right? Because if I own both, why am I going to sell it to myself for anything other than $0? Now, the problem is then when I look at the team's profits, it's going to look like their net, that is a great reduction in possible revenue. Because if they wouldn't have sold their broadcast rights for $0 and sold them for, I don't know, 50 million, well, that would be additional revenue that the team would have. Right? So, just because we've got this vertical integration going on, it might look like the Braves had negative economic profits, but if they would have sold their broadcast rights to another network that the owner didn't own, they would have this additional $50 million and potentially we would see positive economic profits. So we've got to be a little bit careful here when we see things like broadcast networks and teams owned by the same people, because we can't solely look at their reported profits, because integration would kind of manipulate those a little bit, right? Vertical integration, sorry. There's also been some weird examples in the past. Like there was this was a long time ago. I forget the decade. It was something like the 30s or something. The White Sox actually reported their profits and they depreciated the value of their players. And I think this had something to do with, at the time, they had a rule where it wasn't revenue sharing, it was profit-based sharing. So there was an incentive for teams to report low profit amounts. So they depreciated the value of their players depending on, just like you would depreciate a car or any other asset, for which I think they got in trouble with the league for. So we're just starting to think about all these different kind of ideas, how revenues, costs can come together. If we're trying to measure profits, some of the issues that might arise. Okay. So the next topic we want to move into, right, is the role that leagues play. Okay. So why do we even have kind of centralized league? Well, the idea, even if it's not in sport, is that if you have this centralized kind of league, or if it's a centralized club, it's trying to promote the interest of every single one of its members, right? Now, you can imagine we've already talked about small and large market differences. So the league is working so that all types of teams' interests are at play, right? Not just large market teams. Okay? I mean, think about it this way. If they wanted just to help large market teams, they would allow teams just to do local broadcast network deals, and they wouldn't have any revenue sharing, right? But they do care about the small market team's interests as well. So, the other one that we kind of think about is they set rules, right? This is just to kind of keep the quality of the product high, right? So what the league is trying to do is to increase the demand curve for the sport, not for any one team, but for the sport. If I can increase the demand curve for the sport, every single team's demand curve would increase. So I can do this by setting rules, right? Try to help increase the quality of the product that every team is putting out. So, initially, this was just more of like a competitive thing. Like, we're making sure that everybody agrees that we're playing the game the same way. But, as time has went on, we see leagues alter rules to try to provide a different product that they think is going to be in higher demand. So in the NBA, there's been, let's see, I've got a couple, right? We've added the 3-point line, right? Makes it more likely that teams can kind of come back from behind. It's kind of a flashy, making shot from further away. People like to see higher scoring games. The MLB, Major League Baseball, increased the height of the pitcher's mound at one point, which gives the pitcher more velocity, right? That was kind of like, this was back when they were trying to make it so that pitchers were more dominant. They've also reduced the level of the mound to make it better for the batters because they realize people actually like to see home runs and higher scoring games. Helmet to helmet rules. They realized, NFL said, well, look, this is really looking bad. All these concussions and people having CTE down the road. It's not making our product look good. It's actually causing some people to not want to watch. And so we start to change rules to make it to look a little bit more safe. Maybe shootouts versus an overtime, or you can think about in the NFL, changing overtime rules. All these things are to try to get it so that the highest number of people, or increase the value that people value that sport they're watching, they try to maximize that, right? So all these rules are try to get basically an increase in the demand curve for that sport, right? And I guess maybe that's a cynical way of looking at it. Maybe the league really does care about CTE, but I can guess if they're operating these like companies, they only care because it's affecting the bottom line, right? Because people don't like to see kind of these helmet-to-helmet collisions, okay? We've also seen some off the field or out of the game, I don't know, I said off game here, but off field issues that also try to help improve the quality of your product. So some good examples of this, they don't want players to bet on games because they don't want people to think that this is all rigged, right? They don't want fans jumping on the field, disrupting games. People don't like seeing, kind of a break in the action or having to wait till they remove them. Performance-enhancing drugs, so setting steroid policies. They've realized people potentially don't like it when they feel an event is unfair or that someone has an upper hand. So they've created kind of these off-the-field issues of, making sure that they drug test players and things like that. So these are just a few of the examples. You could come up with a ton of different examples. And once again, if I'm thinking here about project ideas, one thing that could be interesting is if you're interested in a certain, couple policies that a league has changed, there's actually a way with regression that we could determine whether or not attendance or whether or not overall league revenues went up or down, comparing the pre to the post of that policy change, okay? I had a student last spring, and they were interested in, this is kind of an ambitious project, but they used the three-point line to look at how players change their behavior around the three-point line. So how much more likely were they to take a step back and shoot a three if they were near the line? Because you've got variation in the three-point line. It's not the same distance all the way around. So you could actually have two shots taken at the same distance, but one is worth three and one isn't. Obviously, there are different angles and things. And then say, okay, based off what we saw here, what would we predict if we put a 4-point line in at this point on the court? Because there's much fewer shots taken back here, so we could kind of use what we see with a 3-point shot and predict what we would see with this 4-point line. Or any other kind of change in policy or change in a rule you're thinking about for these leagues. Okay? Any questions on that? That shouldn't be too bad. All right, so now we get to kind of a more interesting, I think, idea, and especially it's pretty relevant right now. So leagues are also responsible for kind of okaying whether or not different owners can purchase a team, whether or not a new team can join the league. And so the leagues have influence over the size, right? Or limiting the entry into this league from other teams, right? I can't just go start a team in Portland, Major League Baseball team in Portland, and join Major League Baseball unless they let me, okay? So how do we choose this optimal size? So I feel like I'm get this wrong, but what? There's 32 teams in baseball and football. Is there 30 or 32 in basketball now? I think there's 30. And check me out. Yeah. So how did they come up with those numbers, right? How did they decide on those numbers? Why did every league kind of arrive at those? There's differences across leagues, especially if we go back in time. There used to be a lot more variation in the optimal size of a league for different sports. So we can kind of think about it as every single time I add a team to my league, I am going to add some additional revenue, right? If I'm the NBA right now and I do allow a team to go to, I don't know, Las Vegas or some other city, they will bring additional revenue into the league, right? However, if we think about the process in which leagues would allow teams into their league, if I was starting a brand new league, let's say, I don't know, the NFL decides they're done, and a new football league pops up. What's the first city you think they probably want to have a team in? There's a couple different ones that could probably be right here, but yeah. New York, probably my second guess would be LA, Chicago, Boston, right? I'm thinking about, there's definitely some cities where I know a team is going to be able to generate more revenue than if they located in Charlotte, North Carolina, right? And so if we think about the additional revenue, that's marginal revenue, I'm going to choose the city, right? Or my desired city would be the one that would allow the highest additional revenue, to have the highest marginal revenue. But as I add teams in different cities, right, the next best available city, the marginal revenue would be a little bit lower. And then the next best city was a little bit lower. And so eventually I'm down to adding teams in places like Charlotte, right? Or I hate to pick on Indianapolis, but when we compare that to most cities in these major sports, it's a pretty small market, right? So I'm going to have this decreasing marginal revenue curve, right? Now, at some point, I probably get to where if I keep adding teams, the additional revenue brought in could actually be negative, in the sense that it starts to hurt the overall competition. And so people don't like to watch it, you know, the games when that team plays as much. So maybe I see kind of negative revenue, because now when the good teams play this bad team I added, I don't get ticket sales to be near as high. So we usually don't think about that part of marginal revenue, because we would never get to that point, right? However, we can also think about, if I only, you know, instead of having 30 teams, if I only had 10, well, I could leave room open for another league to kind of, so let's say there are, the optimal size would be 30 teams, but I stopped my league at 10 for whatever the hell reason I did that for. But I took the 10 best cities. Well, there's still 20 cities, which an NFL team in there could be profitable. So another league could start, have a 20-team league, and compete with me, right? So, you know, I don't want to choose too few teams. I don't want to choose too many, right? I can also think there's going to be additional costs to adding in additional teams, right? If I only have teams, you know, 5 teams and they're all in the Northeast, I can greatly reduce travel costs, or, you know, administrative costs rise as I add more teams. We can kind of think about, you know, maybe you could argue that it's not increasing very quickly, but we're still going to see that as we add more teams, the marginal cost of adding each additional team, right, starts to increase, right? That marginal cost curve we're going to see for the number of teams, right? We're going to add kind of the lowest cost, you know, have the lowest cost for the first team, and then costs continue to rise. Marginal costs continue to rise. Okay? If you really wanted to, you could keep this constant. If you don't buy that story based off the data, though, we see that there is a slightly increasing marginal cost curve here to adding additional teams. Right? You know, if we think about in more recent years, and when I say recent, you know, probably the best example we saw where we had a real boom in some of these cities was probably like the 90s, maybe early 2000s. We saw a lot of these leagues grow a little bit. And it was really kind of this increase in income. Populations in some of these big cities were increasing. And just a general interest, we saw, you know, the money spent on sports was increasing as well. So if anything increases our demand curve, then we can think about it likely also is going to increase the marginal revenue curve for the league when they add additional teams, right? If there's just overall more interest in NFL football, right, well, now the marginal revenue from that very first team I add in New York is going to be higher than it was before. So anything that's going to shift the demand curve for the sport also is shifting that marginal revenue curve for the league, right? Because they're providing that, their product is providing games of that sport. Okay? And, you know, these increases in demand, we can kind of think about as a upward or rightward shift. Same kind of idea. Our marginal revenue curve will push out or up into the right and lead to a higher equilibrium number of teams in our league. So I'll kind of draw you some examples of this. There's I'll post on Canvas a PDF called Theory of a Club. It's like not a fun read or easy read, but it goes a little bit more in detail into why we see these increasing marginal costs and kind of predicting where the optimal size of clubs would be, kind of using this club so that it's not specific to sport, but kind of even everyday kind of interactions with individuals. So I think I left this slide blank, yeah. So we'll go here. Maybe? Waiting? There we go. Oh, that's something in the chat that I missed, sorry. Okay, yeah, someone set me straight on the number of teams, right? So NFL is the most, and we got MLB and NBA sitting right there. So how do they arrive at those? So all we're really thinking about here is the decision that a league faces is how many teams should I add, right? What's the optimal number of teams? And we're measuring kind of revenues and costs, so we've got dollars on that y-axis, right? All we're saying is really that there's this decreasing marginal revenue curve. And I said, maybe you don't believe it's very steep, but we also have this increasing marginal cost curve as well. So each additional team that we add is going to have a slightly higher marginal cost than the one before it. Each additional team we add to our league has a slightly lower marginal revenue than the team we added prior to it. And from there, it's just like most economic decisions, what's the optimal number of teams? Well, and I'll call this, I guess, T star, the optimal number of teams. It's wherever the marginal revenue of the last team added is equal to the marginal cost of that last team added. Okay? And kind of think about it here, each team that I'm adding brings in more additional revenue than the additional costs. And so it's increasing my profits, right? The change in profits is positive, up to the point where that marginal cost and marginal revenue are equal to each other, right? So it's really kind of, this is very similar to decision making we looked at in other things, right? If demand was marginal benefits, well, to the league, marginal benefits means marginal revenue, right? Additional revenue. And then where does that equal their marginal costs? Before we were thinking about marginal costs, that was our supply curve. Now, first of all, are there any questions on this before I keep moving? Okay, so let's say, and I think I have this in some slides, so I'll kind of go along with that same story. I think if we went back, I'm not good with history, so I forget the year, but there was a time where the National League in baseball had 8 teams. So let's say they chose the number of teams and they decided the optimal number of teams was 8, right? However, if this was the actual revenue and cost structure, they could have added several more teams, right? And still seen an increase in profit for the league. Okay? So the problem is if I select a number that's too low, and let's say this optimal number here was something like 16, what could happen in a situation like that? If I wanted to, what might I want to think about doing if this league is choosing a lower than optimal number of teams? Yeah.
I mean, wouldn't another league come in?
All of this profit is sitting on the table, right? If I can start a league and have my own 8 teams, I can basically get all of that profit that the other league's leaving out on the table, right? This difference between marginal revenue and marginal cost. So if I kind of, look too low, and maybe that there's enough demand out there that I left open the ability for another league to start. Okay? And that's actually what we saw in Major League Baseball. And like I said, I think I have the years on the slide in a second. But basically, the National League kept their number of teams fixed at like the largest 8 cities. But they didn't realize other cities were growing quite rapidly in population and seeing rises in income, that there was several other cities out there that they could have started a team and added to their league. Well, they didn't, and the American League came around and kind of started an 8-team league as well. Okay, you can think about maybe maybe it was that the National League, if we're trying to be nice to them, maybe they thought, and they evaluated the marginal revenues, and they thought they were way down here, and then over time, they didn't realize the demand for the product was growing, populations in other cities, really all cities everywhere was growing, and they didn't realize the marginal revenue curve had crept up quite as high as it did. But I think that's probably being nice. They were probably just being not good at their job, right? Not evaluating the additional revenue that was out there. Okay. Any questions on this? Yeah.
Has there ever been a situation where like
dropped a team, so reduced the size of their league.
Yeah, so it went from like 30 teams to 29.
That's like an economic history question that I don't know off the top of my head. I would think that, I'm trying to think, because I've looked at what's happened over the years in different leagues to where teams are located. I'm trying to remember if there was ever one when they went down in number. I'm sure, you know, if we looked outside the main three, I'm sure there is like, or main fourth, there's probably a sport where that has occurred. I think Major League Soccer started out with more teams than it currently has. I could be wrong about that. Or there was one point where it dipped. But yeah, I'm not sure off the top of my head if that's occurred. Now, how would something like that occur? Well, it's basically you just think that the overall demand for the sport or something has fallen, right? Now, we've seen teams change cities, which is likely a byproduct of when we're thinking about this team right here. You know, I don't know, maybe this is, you know, before this used to be Oakland. And then at some, you know, maybe over here was, I don't know. I always use Nashville as an example because there aren't a lot of major teams there, but it's like growing rapidly. And so maybe at some point, right, the marginal revenue curve might look the same, but cities are kind of like switching, right? So that's why we see teams move from different cities, but I don't know if they've ever reduced the number.
I mean, I know the NFL has, like,
One season they went down, right? Because the transition of teams left them without.
I don't.
Are you talking about like when the Browns left?
No, I'm talking about like really early.
Oh, early on, yeah. So maybe early on that might have happened where they reduced the number. Yeah. Well, we can for sure see it in other leagues, right? Usually the leagues just end up going away, like the XFL and the AFL and things like that. But yeah, good questions. What else? I want to say something else here. Thinking about, I can't think of it now. But if it comes back to me, I'll come back to this. But you know, that should kind of get at most of what we want to think about when choosing the optimal size of leagues. Okay. All right, let's go back here. Okay, so this is the story that I had kind of already mentioned. Was at one point the National League had 8 teams in basically all the major cities, and then other cities like Cleveland, Detroit started to grow. The National League stayed at 8. Somehow they perceived marginal revenue to be too low. I said that's probably being generous. They were probably just falling asleep on the job. And the American League kind of started to its own league and was able to kind of pick up those cities that the National League wasn't, where marginal revenue was still greater than the marginal cost, right, of adding that team to their league. Okay. So we kind of already covered this. So let's think about this a little bit differently. How do I think about this? So we've got a sample question. We can start to think about questions we could analyze given what we now know about kind of how teams are choosing the optimal number of teams. So let's say we've got 2 competing leagues now. So let's go back to think about like when the American and the National League existed at the same time, right? But they weren't part of Major League Baseball. They were independent. So let's say both these leagues have similar or identical marginal costs, but League 1 has a higher number of teams than League 2. What has to be true about the marginal revenue of the last team added in League 1 relative to the marginal revenue of the last team added in League 2? Right? So here's where we want to make an important distinction, right? So let's start to kind of draw this, and I'll kind of point out some things, right? So both these teams have the same marginal costs as they add additional, right? They kind of have the same maybe cities available to them, right? So got number of teams over here. We've got this slightly increasing marginal cost that both of them face. And so you could almost think about this as, MC1 is equal to MC2 here, League 1 and 2. And now I'm going to have to remember without switching my screen. I think I said League 1 had a higher optimal number of teams. So let's say we've got the marginal revenue for Team 1 And kind of the optimal number of teams for League One is right here. League Two has a smaller number of optimal teams. So maybe they were something like, here's their marginal revenue, and they're choosing kind of this lower optimal number of teams. Okay. So it's a little difficult here. But if I have increasing costs, right? So if I have increasing costs like I have here, the league that targets a lower number of optimal games, what is true about the marginal revenue of the last team added in League Two relative to that in League One? The entire marginal revenue curve is lower. However, the last team, that marginal revenue in League Two, is going to be a little bit lower, right? If I go over to the y-axis, that marginal revenue of the very last team added is a little bit lower in that league that has a smaller optimal number, right? And that's simply a byproduct of having these increasing marginal costs. Now, if for some reason someone told you that these had constant marginal costs, right? The cost of adding each team was exactly the same no matter how many teams I had, what would be true about the marginal revenue of the last team added in each league? If this was a completely flat marginal cost curve, you can think about it as the marginal revenue of the last team added would actually be the same in both leagues. However, we know that we kind of have this increase in marginal cost, and so that leads to it being a little bit lower, right, in the league that had a lower number of optimal teams. Okay? Any questions on this before we keep going? So here, the point I want to make is sometimes we'll be interested in the marginal revenue of the last win or the last team added. That's not the same as the entire marginal revenue curve, right? The marginal revenue of this team was higher than the marginal revenue of that team that we had, right? So we're thinking about the very last team added here, okay? Kind of make an important distinction. Same idea where demand can be higher, the demand can shift, but we can be at different points on the demand curve, right? Each quantity we consume has a different marginal benefit. Each team we add has a different marginal revenue, okay? Any questions on that? We're okay with this? Or any questions in general? All right. So we'll go back here. There we go. So here, actually, I don't remember how it was phrased. The marginal revenue of the last team added in League One, so that would have been actually that it's greater than, right? I think I said it reversed. The marginal revenue from Team 2 was lower, but the way that this is phrased, it's how do we think about the marginal revenue of the last team added in League One relative to Team 2? So there we would have had the marginal revenue of the last team added in League One was actually a little bit greater. Okay. Any questions before we keep moving there? So we should have had greater than the way that the question was actually phrased. I think I said it kind of in reverse. Go here. So, we've got someone kind of mentioned this already, but the NFL has 32 teams. These three leagues have 30. And we've got, different sizes if we look at conferences in college football as well. So this brings up kind of an interesting point. We'll get a kind of a look into maybe not a completely linear demand curve. So one thing, I know that this is a relevant issue. I know the NBA is talking about adding additional teams. So if we're really thinking about what types of cities do they want to target, well, they're trying to target the cities that have would bring the highest additional revenue to the league. Okay? That's likely going to be a byproduct of population, income in the area, maybe businesses, companies in the area. We talked about their influential over luxury suites. But I want to tackle this idea of why do we have conferences have different sizes here, right? Well, first of all, when it comes to college football, we might have demand for college football, but that demand might vary depending on what region of the country we're at. If you go to the South compared to the Pacific Northwest, you're going to find very different demand curves for college football in those areas, right? So, we see this variation that exists. And I think when I wrote this, I think the Big 12 may have added, I think they did add, increase the number of teams that they had. I feel like when I added this in, that this might not be true now. I'd have to look into this. But it brings up a really interesting idea that at least at one point, there were conferences that still had less than 12 teams, where you need 12 teams to be able to add a conference championship. Right? So this is an interesting idea that would lead us to think about something that, I don't know, maybe you've seen this in other classes. I know that we talk about like kink demand curves in terms of monopolies, sometimes in 201. I don't know if every professor's done that. So let's think about, why might this idea that I need 12 teams to have a conference championship create some pretty interesting changes in the number of teams we see in each conference, right? So let's go back to what we were thinking about before. So the optimal number of teams, and honestly, maybe the cost in adding additional teams to your conference, I imagine the marginal cost curve in college sports, when it comes to the number of teams, is probably much steeper, right? It's harder for them to, travel costs might be higher, providing scholarships to additional students, things like that. So let's go here. Think about, we have this increasing marginal cost curve. So prior to there being kind of this college playoff system, I would say we were probably thinking about that adding additional teams to my conference probably looks something like this, right? I have this marginal revenue curve, and maybe I would arrive at 10 teams. Right? The thing is now, what we know is that at that 12th team, right, once the college football playoff series has started, so there's now 4 teams, but in order to be selected as one of those teams, let's say this isn't, you probably argue that this isn't necessarily the case, but I would think 99% of people would argue it'd be very difficult to be selected as one of those teams if you didn't have a conference championship win, right? If you didn't win your conference championship. Now, there's some exceptions to that, but if I didn't even play in one, I'm going to be behind all these. First of all, I have one fewer game, one less game played. I'm going to have a high quality win if I can make it to that conference. And so having that 12th team now makes me eligible to have that conference championship, which increases the odds of the best teams in my conference making it into this college football playoff series, where there's a ton of additional revenue that my college can earn. So that 11th team added, still lower additional revenue, right? It would be the 11th best team, but the marginal revenue is less than the marginal cost, so I really wouldn't want to add that 11th team. But if I could get to that 12th team, now the additional revenue takes a huge jump up, right? Because once I get that 12th team, now I have the opportunity, the ability to get into that college football series and make additional money, right? So we would see maybe this jump kind of in that 12th team and the amount of additional revenue that 12th team would bring in to that conference, right? So that's why, I think, I don't know what the year was, right? The Big Ten added, instead of adding one team, they added 2 teams, right? I think it was Maryland and Rutgers, right? Because they knew that, adding an 11th actually hurts our profits, right? You can think about here, the costs are greater than the revenue. I'd actually be eating into my profits. But if I can get to that 12th one, I just jump that marginal revenue up quite a bit. Well, now here's all this additional revenue I could earn as well, right? If I wanted to kind of keep increasing the number of teams. So, it's not surprising that we see these teams trying to get a higher optimal size to be 12. We don't see teams that have just 11, because that 11th team probably doesn't add anything to them. But if they could get to that 12th, it opens up this huge additional revenue resource. Okay? So that topic is kind of interesting to kind of relate to league size. And it's not a professional sport, but conferences essentially operate like mini leagues, right? They're like a league within a league, but they would still want to kind of choose the optimal number of teams to be in their conference. I would give an example maybe where conferences have fallen short. How long ago was it? The Big East in basketball had like an outrageous number of teams in it. And it actually started to kind of like be detrimental. People weren't as interested in watching their games because there was some really high quality, but there was some really low quality teams too. right? So they probably chose something like way out here that was actually at an additional revenue that was very, very minimal and well below the additional cost that it was generating. So we see conferences get it wrong from time to time. All right, let's go back here. So we talked about that already. Where are we on time? I think we got what, 20 minutes. So I think I'm gonna play around in Excel a little bit, and then we'll kind of talk about that paper and touch on some linear regression ideas. So we'll stop at team location. I thought I was gonna get to, maybe kind of show you where we could look at cities and the number of teams I have, but we'll start with that next class. So let's look at this Excel file that I have on Canvas. So it's called Forbes Team Evaluation. So I think this was, I basically pulled the last year's the different NFL, MLB, NBA, and NHL teams. Forbes gives them kind of these valuations and has some of the reported revenue, operating income. I've merged in the populations of these cities, but also the populations of the metro. Right, so like if you look at the population of Indy, it's much smaller than the population of the metro area. Same thing with most cities, right? What city would this be? I'm guessing New York. Yeah, so New York City has 8 million people. The metro area has 20. Right, so we want to kind of factor that in, that these are people who are still likely to attend the games. Right. So thing that we can do in Excel, and I'll zoom in here. Right, is let's say I wanted to find the average revenue, or not revenue, what do I do here? Kind of the change, right? Whatever their, I think this was Forbes valuation, right? So a couple functions that we might want to be familiar with is this average function, right? So I don't know, if you guys have taken 221, I incorporate a lot of Excel. I don't know how much everyone else does. And so here we're going to be using things like cell references. So this is saying, take the average or find the mean using the observations C2 through C31. So those are cell references, which says start in cell C2, take that value and every value all the way down to C31 and calculate the mean for me, right? So that's what that average function does. Now, if I'm typing this in, I can use that average formula, go over, select that kind of valuation, hold Control-Shift, or if I'm on a Mac, hold Command-Shift, hit the down arrow, and it selects the entire range of data for me, right? Hit Enter, and I've got my mean in there. I can use the same process, just selecting that variable that I'm interested in finding the mean of, but maybe I want the variance. So the variance equation, if we have population data, which most times in the sports world, we actually will have population data in the sense that I have every single MLB team here, right? So I have the population data set. So we're going to use that var.p, which calculates the population variance for us, right? I then just select that same range of data where my variable is, and it'll find my variance. Okay? I've got equations for the minimum, equals min. Select that, it'll report to me the minimum valuation. Equals max, reports to me the maximum valuation. And then if I want the range, right, the range of the data, it's just the difference between the maximum minus the minimum. So all I did there was, I said I want to take the maximum and I want to subtract the minimum. And I don't have to type the numbers in. All I have to do is select on the cells that the numbers are in. Right? So these are some basic statistics. When you get to your project, if you're wanting to kind of calculate some of these, this is how we would do it in Excel, right? Once you have those variables, these are some pretty basic descriptive statistics that we could calculate. Just out of curiosity, raise the hands for those of you who are here. How many of you had some use of Excel in your 221 course? Okay, so most, not everyone. So I'll try to do some review. If you have questions as I'm doing these things in Excel, make sure you ask. I'm not going to go through a complete review, but we're not going to be doing anything crazy in Excel. It's just kind of like these basic statistics, and you'll have this file to always go back and look at. Pretty easy. I could find the average population by, equals average and select that variable. So, you know, this should be the extent to which we want to use Excel to calculate some basic statistics. But what I could also do, and let's say, I think the NFL is the one. I'm going to use the NFL here. Let's go to view, blow this up a little bit more. So let's say I've got all these valuations of these different teams, but I also know what their metro population is and what their city's population is. So I want to show you, kind of highlight something where if we're using the wrong statistic, we could lead us to very, very incorrect conclusions, right? So in Excel, right, if we go to data, you might have this data analysis tab here. If you don't, you should be able to go to file, options, then we go to this add-ins. We go down here to manage, hit go, and make sure that the analysis tool pack is selected, right, has a check mark. Once we do that, under the data tab, that data analysis shows up. So that was file, options, add-ins. We manage the add-ins. We make sure that tool pack is selected. Hit OK. Now that I have this data analysis, I can start to run my own regressions, right? So maybe what I'm thinking about here is that valuation, right, that I have here, this current value. Well, I guess I should match the words up. So my current value of the team, let me scroll over here so we can see this all on the same line. There's some intercept plus a slope times whatever that city's population is, right? I think that there is some relationship between population and the current valuation of the team. Now, you know, what that kind of relationship is, or what that slope is, if I add one more person to a city, how much does the current value change? Probably a very low amount. But if I can determine what the effect of one more person is, well, the effect of 1 million more people would just be that times 1 million, right? So I might want to run this regression, right? So remember we said my left-hand side, or my Y, or my dependent variable, and here's my X right-hand side, or independent variable. So if I click on this data analysis tab and I scroll down, I have this regression option down here. Okay? I click on that, hit OK. I can select my Y variable. So my Y variable here, I'll go over, was that current valuation. Right? So I'll select on the heading, hold Control Shift, Command Shift on a Mac, hit my down arrow, it selected the entire data set, or the entire variable for me. I then want to select my X variable, and there I was interested in population. Right? So Control Shift, Command Shift on a Mac, hit the down arrow, click this little guy, it sends me back here. Now when we are running our regressions, one thing we want to keep in mind is if I select these labels, I need to make sure that I click the box, right? Otherwise, I've got a data point that's words and not numbers. I usually put this on a new worksheet. We want to make sure that the constant is 0. That's not selected. You don't ever want to select that. The only thing you ever want to kind of select is that labels if you select them. We hit OK, and we get this regression output. So the main things that we want to focus on for today are these coefficients. So these essentially are the estimates using the data for, where is it? Where did I type it in? It's the estimate for what this intercept A is and the estimate for what that slope B is between population and current value. Okay? So when I'm looking at that output, it's essentially telling me that if I were to add, if the X variable goes up by 1 unit, which here would mean add one more person to that city's population, the expected value of the team would increase by $97. Doesn't seem too wild to me. I mean, if we think about, the effect of a million people, right, would kind of increase the valuation quite a bit. But I mean, these valuations, if we go over here, these are billions of dollars, right? So, $97 additional from one person isn't wild. However, if we go back to that regression output, we look here, is it statistically different from 0? So we can only tell if an estimate is statistically different from 0 if that p-value is less than whatever alpha we've chosen. So we want to say things at like the 90, here we go. I'll write this out. So we've got significance levels and confidence levels. If I want to say something with 90, 95, or 99% confidence, that's the same as saying it's significant at the 10, 5, or 1% level. Right? Kind of usually we say things, I think it's easier to think about, I'm saying this with 99% confidence, which is really also kind of said differently, 1% significant level. Right? Our alphas for those levels become 0.1, 0.05, and 0.01. Basically our significance levels, but in decimal form. Okay? Move the decimal point 2 places. So when I look at this p-value, I can only say that this coefficient is different from 0 if my p-value is less than the alpha that I've chosen. So I can only say that there's a statistically significant effect if the p-value is less than alpha. So here I look at my p-value, it's just under 0.05, so it's going to be less than 0.05, and it's going to be less than 0.1. So I can say with 90 and 95% confidence that this relationship is significantly different than 0. Now I can't say with 99% confidence that it's statistically significant from 0 because my p-value is actually greater than my alpha there. Right? But still, 90 and 95% confidence is pretty good, right? So, you know, I've found pretty strong evidence that population has an effect or is highly correlated with the valuation of a team, right? Which intuitively makes sense. Right? What is somewhat interesting, so let's say I go back to run a regression. It keeps in my old selections. So I'm going to keep my y variable the same, but instead of the population for my x variable, I'm going to use this metro population and see if that produces different results. Right? So I'm going to hit OK. I'm going to zoom in for us so we can see things a little bit better. Now we look at these coefficients. Looks like the relationship, right, the increase isn't quite as large, which maybe makes sense, right? Maybe people within the city are more likely to spend money on that team than people who live a little bit further away from where that stadium's located, right? So it's not that surprising that the coefficient is now lower, but notice it's much more statistically significant, right? The p-value of 0.001 is going to be less than every single alpha that we had there, okay? So, you know, we could play around with this. We could do different variables, but this is how you run your own regressions in Excel, starting to think about, once again, interpreting coefficients and kind of looking at p-values there. Okay. Any questions on that before we keep moving? We can go back to that file. Right, I'll save this file and just post the regressions there if you want to kind of go back and reference them. But I did want to mention this, or talk a little bit about this paper before we get out of here. Okay? So I think this is a very interesting paper, and we won't kind of go into everything that it talks about, but just kind of the main findings. So can anybody take a look at this paper prior to class today that has anything that they want to say about it? You guys are killing me, right? So I put these up there because I want you to read them. So on the online quiz today, and what I'll probably start doing on Thursdays, is putting up a question or two that relates to the reading. That way, I'm giving you a little bit more of an incentive to make sure you're kind of going over it prior to us being in class, okay? But, you know, one thing that I think is interesting about this paper is their general idea is, do we see changes in player performance based off of whether or not they feel secure, right? That's kind of the general idea. And more specifically, when would they not feel secure? If they're in the last year of their contract and they have to sign a contract after this season, right? So their idea is, do we see them perform better in that year of the last year of their contract, because they're going to have to sign a new contract the next year? And do we see them play worse once they've obtained that contract, right? Once I sign a 10-year deal, maybe I put in a little bit less effort into practicing. Maybe I take it easy, right? I coast. And so that was kind of their general idea. So what they're thinking about is, no, actually, we'll skip this equation for a second. Oh. Yeah, so someone's saying here, performance is better right before the contract is signed. Yeah. So their idea is, how can we statistically test this? So what they used as their Y variable was a bunch of different performance measures. So, points scored, rebounds. So this is in the NBA. They also did some composite score, which tried to like weight all of these different statistics, like points, rebounds, take them all into consideration, but just represented by one statistic, like kind of like the idea of, what do they call it? Value above replacement, the VAR. And like, I think they use that more in Major League Baseball, but basically one statistic that's measuring the quality of the player or the quality of their play. So once they had that as kind of their dependent variable, they said, all I'm going to do is create this indicator or dummy variable, and it's a 1 if they were in the year prior to their contract being up. And here, this post is a 1 if it was the year after, like that first year after they signed a contract. So kind of our comparison group is all the years in between, like all the years they had a contract, but it wasn't the first year of the contract and it wasn't the last. Right? So now this coefficient on pre, a 1 unit change in this X variable is going from 0 to 1. It's a dummy, it's an indicator variable. It can only be 0 or 1. So the idea would be going from not being in that last year of your contract to then being in the last year of your contract. Beta pre here is the predicted increase in your performance by being in that last year of your contract. Right? So we're going to look at that kind of pre coefficient to tell us whether or not, if it's positive, players are performing better in the last year of their contract. If it's negative, they'd be performing worse, which doesn't make a lot of sense. So we kind of probably already know what the answer is, right? So if we look at kind of their main findings, right, and they have a bunch of other, it's not just age. They had some other, I think, I forget. There's another table in the paper. I'll pull the paper up in a second, where they have a bunch of control variables, like for how the player on average performs, right? And then kind of what their performance was, obviously, in that the current year is what they were using as the Y variable. So here's this composite ranking they came up with that tried to factor in all these statistics. But they found in that year prior to the contract needing to be signed, or the last year of your contract before it's up, players increase this composite rating. Or this composite rating was trying to capture the quality of their play, right? So we see players perform better in that last year of their contract. There's this additional incentive because they need to sign a new one. After they sign, there's a significant decrease in their performance as well. Almost the exact same size, right? So, and we talked last week, 2 stars. So 3 stars meant significant at the 1% significance level or 99% confidence. 2 stars is significant at the 5% significance level. So these are statistically different from 0. They're pretty statistically significant effects. And it shows us that players are performing better in that last year of their contract and worse after that first year after they sign a big contract. And you can kind of break this down. They use different dependent variables here. Points scored goes up by almost a point. Rebounds on average goes up by about 0.3 rebounds per game. I think these were all per game measures. So almost one more point per game, right? 0.8 more points per game. And really everything increased in that year right before your contract is up. And then kind of afterwards, we saw this decrease in this composite rating, but there wasn't really any statistically significant effects if we looked at individual statistics. So pretty strong evidence that players perform better in that last year of their contract when they're trying to sign a new one. Once they sign a big contract, at least, maybe there's some evidence from this composite rating. There's also issues of how they come up with this. Like, how do I choose the weights? Do I weight points more than rebounds? So I'm a little skeptical on that because there's really no evidence in any one statistic that there's any changes when they are in that first year after signing a contract. Okay. Any questions on this? So we got 1 more minute. So I do want to bring it up just because I think it is interesting. They did some additional things with like the length of your contract, if that had any, any impacts. But we really won't talk too much about interaction effects in this class. I might introduce them towards the end. So don't have to focus too much on this table, but they did have some interesting findings where potentially this increase in performance only applied to kind of players who maybe were older, who had longer contracts. So if you want to kind of read the rest of the paper, kind of read more of the conclusion, you can pick up some of these kind of more complicated findings that they had. But in terms of what I want you to be able to interpret, really just this table 3 here, okay? All right, any questions from me before I let you guys get out of here? So you've got that a homework assignment to start working on. If you have any questions, feel free to email me. We can set up a time to meet in person or via Zoom. I would suggest starting to work on that sooner rather than later. Don't save it to like the very last day or two. It will take a little bit of time, okay? So, all right, if there's no more questions for me, I will see you guys on Tuesday. Have a good weekend. Stay safe.